All right, good morning, students. I'm going to help you through, the number 1 on your homework. Make sure that you are using all of your notes that you've taken up to now, the notes on transformations, the notes on graphing, functions, and all that jazz. So this worksheet is really kind of helpful because it asks you for all the main components that you need in order to graph a function. So for number 1, the first thing you have to do is discover its parent function. So according to this function given to us, we have a third power, which tells me I have a cubic function. So the parent function is f of x equals x to the third. And if you recall, the cubic function kind of looks like tangent. That's what we associated it with. It increases to the right and decreases to the left. And it has this continuous sort of shape, right? Next, we have to identify the transformations. So our transformations, first of all, tell us we have a vertical stretch by 2. That 2 is outside of the parentheses, therefore outside and away from x, what's happening to x. So we have a vertical stretch by 2. Next, we have a left 1 unit. According to this 1 inside the parentheses, this is a left movement. And then we have this minus 5 out here, so that's a down 5 unit. Right? So this is how the original parent function is changing. Now let's take a look at this. I've already graphed the vertex, so first thing you always want to do is move the vertex, the starting point of the graph. In this case, the parent graph starts at 0, 0. So we have to move that vertex to the left 1 and down 5. 1, 2, 3, 4, 5. I've already done that. Now for a cubic function, domain and range is the same. All reals. Now to find the x and y intercept, we are going to substitute some values into this function. So that means we have to do a little bit of work off of this worksheet. Okay, so I'm going to move this to the side and create a table. Just like I've shown you in class, I'm going to have x, and in the middle I will have my function, which is 2 times x plus 1 to the third minus 5. And then I'm going to have my y values. So x being the input, y being the output in this case. But for our x-intercept, we're going to have to do this backwards, right? So if I take a look back at the graph, my vertex is here at -1, -5. So I'm going to want to point to the left. I want to find out something to the left of that graph and something to the right of that graph. So I'm going to have to substitute -2 to find out a point. And I'm going to have to substitute 0. And I'm going to have to substitute 1. And you can do more points than that if you like, but it's not necessary. So I'm going to go ahead and substitute that in. So 2 times a -2 plus 1 to the third minus 5. So let's go ahead and work this out. -2 plus 1 to the third. Well, that's -1 to the third, which comes out to be -1. -1 times 2 gives us a -2 minus 5, which is a -7. 2 times a 0 plus 1 to the third minus 5 would give us a 1 to the third times 2, which is just 2, minus 5. 2 minus 5 is -3. Next, 2 times a 1 plus 1 to the third minus 5. Excuse me, guys. This would give us a 2 to the third. 2 to the third is 8. 8 times 2 is 16. Now, is 16 minus 5. 16 minus 5 gives us 11. All right. Now, the last thing we want to find is that x-intercept. So we have to actually set this equation equal to 0 to find out what y is. So we're going to, y would be 0, excuse me, to find out what x is. So 2 times an x plus 1 to the third minus 5 equals 0. Now this is to find our x-intercept. Okay, so first thing we want to do is add that 5 to both sides to solve for x. So we're left with 2 times x plus 1 to the third equals 5. Next, we're going to divide by 2. All right. So x plus 1 to the third equals 5 halves. And we're going to get some decimals here, okay? So we're going to cube root both sides. So this is where you have to open up your calculator. Open up your calculator. Which I do not have. And what we get is x comes out to be approximately 0.36. Okay, so now we can go back and input this into our information chart, our homework. So now I can go ahead and graph the rest of the points here. So let's see, I'm taking a look. I have a -2, -7, which is over here. I have a 0, -3. And then I have a 1, 11, way up there. So it's going to go past this graph, okay? And then I have an x-intercept at 0.36, which is approximately here. Do we have any extrema? None. Our x-intercept was 0.36, comma 0. Our y-intercept is 0, comma -3. Increasing interval, sure. We have an increasing interval from -infinity to +infinity, right? This graph is constantly increasing. So let's go ahead and graph that. Ooh. Down. Okay. Do we have any decreasing intervals? Nope. Our end behavior. As x approaches +infinity, f of x approaches +infinity. As x approaches -infinity, f of x approaches -infinity. And there you have it, guys. I'm going to zoom this in so you can take a closer look. Let me know if you have any questions.